Alright, we're back. Just to wrap this up. And we left off at different ways you could find that p-value of 0.1164. Okay, now from there with this computer virus protection example. Step 7 being just that because the p-value of 0.1164 is greater than the significance level of alpha equals 0.045, or 0.05, sorry, then that's when we fail to reject the null hypothesis. So again, if it's bigger than your alpha, fail to reject. If it's smaller, reject. Then step 8, we fail to reject the claim that 93% computers have antivirus software. We conclude that there is not sufficient sample evidence to warrant rejection of the claim that 93% of computers have antivirus programs. So again, we just kind of took that fail to reject and put it into different terms with context. All right, and so next just want to address a little bit of the critical value method here. Again, this is one that we won't use quite as much. I want to emphasize the p-value method and confidence interval, but just to show you a little bit what the critical value method does. Everything in steps 1 through 5 are the same, and then since we're using that alpha level of 0.05, what that essentially means for critical values is you look for, in this case, critical value of 1.96 and negative 1.96, because those probabilities to the right of positive 1.96 and to the left of negative 1.96 are each 0.025, which add up to that alpha level of 0.05. And so if they're outside of negative 1.96 and 1.96, again, they're essentially rejected. But since our test statistic is 1.57, that's inside that range between negative 1.96 and 1.96. So then we still would fail to reject the null hypothesis in this case, since the critical value also was not in the rejection region. And then number 8 would be essentially the same, just putting that fail to reject into non-technical terms with context. Now for the confidence interval method, the claim of p equals 0.93 can be tested at that same alpha level 0.05, and now with a significance level of 95%. Because again, since we're doing a two-tailed test, we're using that confidence level of 95% since our alpha is 0.05. And then we're just going to use some of our same methods from section 7-2 to create a confidence interval. We would end up getting this confidence interval 0.929 to 0.971. Just to clarify, you get that from having your p-hat value, then kind of plug in everything into this formula here. And so plug it in that 0.95. My critical value for a 95% confidence interval is still 1.96. Inside the square root here, plugging in that 0.95 and then 0.05, which is just 1 minus 0.95, all divided by that 400. Same idea over here, just this time it's plus that critical value of 1.96. Once I would evaluate all that, I'd see that I'd be 95% confident that the true proportion of computers that do have virus protection software would be between this 92.9% and 97.1%. So I'd use all of that to say, since this interval contains that proportion of 0.93, then we would not have sufficient evidence to warrant the rejection of the claim that 93% of computers have antivirus software programs. And so this is one of those cases where it looks like the confidence interval method actually complements the same answer as the p-value and traditional method. Just know that that may not always be the case. Confidence intervals may give different answers sometimes.